we go. So that's the one we want. In there. There. And there you see us just down here, 21 Grasslottsbergen, and you get your bearings down. If you then say import, that will import it, and then you have the plan, and what you do is you put the plan on the plane that you want to do.
Sure as hell ain't my paradigm. Gotta get the funk out of this paradigm. Get the funk out of this paradigm. Gotta ship my ass out of this paradigm.
Highlight this, press erase, and there you then have the plan of the house. There you see, and you can just start from there really, make it as tall as it needs to be, put your roof in,
Sure as hell ain't my paradigm.
if you find the midpoint there.
Out of this paradigm. Get the funk out of this paradigm. Gotta ship my ass
Originally
out
to
of
build
this
the model of the
paradigm.
house,
No, it ain't my paradigm.
what I wanted to do was work out the exact roof area, to work out how many photovoltaic panels would fit on the roof. This is the south facing part of the roof, and this roof angle here is 17 degrees. Panels ideally should be. I've been doing some concept drawings for taking our house off grid, and I've been using SketchUp to do that. It's a really cool program, and you can actually import scale plans. I had some plans of my partner's house here in Sweden, and this one here is actually to scale, or they're all to scale. This floor plan here. So what I did was, by importing the this is the house that I did originally to build the model of the house. What I wanted to do was work out the exact roof area, to work out how many photovoltaic panels would fit on the roof. This is the south facing part of
Gotta
the
get the
roof.
funk out of this paradigm. Gotta ship my ass.
This roof angle here is 17 degrees. Panels ideally should be at 38 degrees at ours.
It ain't my paradigm.
So that's something designed into the system. In terms of overall floor area or roof area, with this part of the roof and the garage roof, we should be able to get a 40 panel, 10 kilowatt photovoltaic system. So how did I do that? Let me just show you now. So file, new, if I open a new screen here, then if I say file, import, those plans I scanned in and put them into a folder on my desktop, which is opened here. This is in my desktop, and this folder is a sustainable project here, and we want to look for PDF. He'll do JPEGs or PDFs. That's the site plan. That's the house plan. So if you then say import, that will import it, and then you have the plan, and what you do is you put the plan on the plane that you want to do, like that. Oops. Okay, so that's there now. Go to this here, sort of get it so that you can see it, perhaps magnify a bit. There we are. And then what I did then is, if you go to your tool palettes and the large tool palette, what I did was I took the pencil and at each corner I cut out this template, so like this, like this. So you cut out your panel. I went round the chimney breast like this as well. I did this a bit more accurately, but you get the idea if you do that. So if you do that there, then what you can then do is you can put a dimension, this is the dimension thing here, just take one dimension. Right, now dimension there. So that was the tape measure. And I know from my plan that dimension of the house was 5.62 metres. So 5.62 metres in millimetres is 5.62 times 1000. It's 5620. So if you changed that to 5620 millimeters, press in, and it says, do you want to resize the model? Say yes. Okay. Then if you click that one, that will get it back to size, and that's then made that how you want it. So the next thing you then do is go back to the pointer. You can highlight this, press erase, and there you then have the plan of the house. There you see, and you can just start from there really, make it as tall as it needs to be, put your roof in. If you find the midpoint there, right, that comes to the midpoint, then you draw up however high up it goes and make your roof. Right, so this just, you can see what we're doing here. I mean, that's just a little bit sort of all over the place, but you get the idea. Just take these down here and just go back to the concept model that I've built, because obviously that's how I imported the plan. I also imported the site plan to get an accurate site plan, and then I placed the house where it is within the boundary. And then this is the garage block that we're planning on building. And what we were able to do was actually try it in different positions to get a feel for how we want things to be. This is our wind turbine. That's just something I just drew kind of freehand. It represents a wind turbine, obviously. But what I wanted to do then is that, as long as your wind turbine is under 20 metres in height, and if it falls over, remains within the boundary of your property and it's not attached to your house, you don't need planning permission for a wind turbine in Sweden. So basically what I've done there is I think I drew a 20 metre high, let's just see, no, a 10 metre high post to mount the turbine on. I mean, that's 18 metres, so it could be 18 metres high. I've got to do some more research on wind turbines. My photovoltaic research has sort of got me home on the panels that we want. I imported this before I actually did the detail on the roof more here. You can see we've got 8 panels down here, we've got 10 here, 15 here, that's 25, 2 here, 8 and 2 is 10, 25 is 35, and then 5 here. We've also got a small garden, a couple of small garden sheds which can take some space, but 40 panels does 10,000 kilowatts, so we've got plenty of roof space south facing which can take that system, and then the wind turbine will fill in the gaps on that. But it's a really good way of just getting the concept. I mean, it took me a couple of hours to work out how to use it and to import plans and scale them and whatnot. Here what I did was the ground slopes, so I kind of approximated the slope here, and again then you can get the idea of how the new building is in terms of roof line and siding, to get an idea. And I haven't gone into much detail with the modelling of the properties itself. It's really just for roof area purposes, visualisation, and there you can see what a fantastic tool this is. This is a video following up the sustainable energy report which I've been doing for my partner's place where we live in Sweden, and Homer Energy is a Windows-based software which allows you to download and then work out at your location how much energy you can generate from solar radiance and wind energy, and you can add in other components to a system. You can have it on grid or off grid. So if you click on their products tab, Homer 2 is the trial version, which is the paid version, and then there's the legacy version which you don't have to pay for. So you download that, set it up. I've got 3 other windows open. One is this Northern Solar. There are plenty of solar panel kit things that you can buy them separately. This is just so I've got some numbers to crunch in Homer, and I'm looking at this kit here which has an inverter, a mounting system, cables and connectors, and 40 250 watt monocrystalline solar panels, and that package from these people is 133,000 kronas, which is about £12,000. We already found another company that can do a similar package for 100,000 kronas. Obviously, moral of the story, ship around. I saw on my Facebook homepage the other day that Home Depot are doing a similar output by mail order package. The 100,000 quote we got was actually fully installed, which is pretty good. Then this next page here is a UK company, and they've got lots of interesting information on how much energy you can expect to generate on average from different types of solar panels, and how many square meters etc. you need on your roof or on a freestanding ground mounted system, and they also tell you how you work out the wattage of a system to the amount of kilowatt hours you're likely to generate. And then the last site here that I've got all small wind turbines. This is a portal which says it's got basically all the wind turbines you can buy and their outputs and whatnot. The one that I'm particularly fascinated with is the energy ball, which they've got here. Here we are, the energy ball V200. I saw one of those sold on eBay recently for $750, and I think well, you can see you can buy this one from the distributor in the Netherlands for 4,900 euros, and it's 2,250 watt. We would need 2 of those in the system that I'm going to show you that we've been designing. So there's lots of information. Wind power is not considered as economically viable as solar voltaics right now. During the winter you can make up your power input, so they are still viable, not as viable, and of course they run during the night as well if it's windy. So wind turbines are viable at our location. Depending where you are, wind turbulence, surrounding sort of geography, it may or may not work for you. We've factored it in, and it works for us. We're at quite a high altitude here in Sweden, in the south of Sweden, we're 94 metres above sea level, and of course by the time you add a mounting pole for your wind turbine, that's kind of up there. It's you know, fairly high up really. So anyway, those are the 3 sites that I've got open. So you download your Homer, and this is the screen you get when you open Homer. So what do you need to do? What you need to do is add the components that you're going to be using. The first thing you have to do is work out what your consumption of electricity is. You can do that from your electricity bills. So you add in your primary load. I'm going to have a photovoltaic system and a wind turbine, and you also need a converter. This is your inverter. So press OK to all of those, and that will then put your system there. And then the other thing you need to do is, if you're going to be on grid or off grid, if you're going to go off grid, you need batteries, possibly a backup generator. As we are already on the grid here, generally people feel that it's best just to use the grid as your battery, especially if there's a purchase back for any surplus that you make. So if you're creating a surplus, you have batteries, you store that surplus and use it when you're not producing enough energy. But if you have a grid connection already, you can actually sell your excess production back into the grid, and hopefully if you're generating more than you use over the 12-month period, that means that you get a net payment back. Either way, it can greatly reduce your energy bills one way or the other, and it's a question of mixing and matching for yourself. So the next thing then that you have to do when you add those components is specify each of the components. Now for your primary load, like I say, you do work that out with your bills, so mine. In the trial version you can't save what you do, so you have to put them all in again, which is a bit of a laborious task. We start in January here. January, right, okay. Our total power usage we worked out is 12,733 kilowatt hours per annum, and our peak months for usage are December, January, February. The lowest months are May, June, July, August, and then in between is March, April, September, October, November. So anyway, what you do is you have to work out your hourly kilowatt hour load, and I've just averaged hours out, so I'm not making any distinction between peak supply low supply, which I think this can do, but this is just to get in the ballpark. So 3.47. That all in there, and you can't even drag and paste, so you just have to do it laboriously. I'm just going to do this, and I'm going to cut the video afterwards. Cut it down, so miraculously they'll all be there, but each 24-hour period. I'm just going to say pause. Right, okay, that's all of those in there. So January, we've got 3.47 kilowatts every hour. And so this is the graph here. So that's your load, primary load. Right, next up then we need to put in the solar resource. Now what the solar resource is for your coordinates, your latitude and longitude. You can register at NASA and it does it automatically, or go on the site and get it. We're +1 Greenwich Mean Time here. Google Earth, if you put your address into Google Earth, the coordinates of your address will come up for this. Right, here we are in Google Earth. Put your address up in the search bar, press search, and here we go. So that's the one we want, that one there. Get you there, and there you see us just down here, 21 Grasslottsvägen, and you get your bearings down in the bottom corner of the screen here. 56 degrees 19 minutes 16 seconds and 12 degrees 58 and 56 minutes east, and the elevation is 94 meters. So that is what you do there. Then the next thing that you need to do is go to the NASA website. Here we go, here's the NASA website, and you can see the address eosweb.larc.nasa.gov/SSE/, and you want your meteorology and solar energy. You can see the home tag there. You want data tables for a particular location. And this is where you just put in your latitude and your longitude. So let's just get those again. 56 degrees, 56.19, and longitude is 12.58. You can't put the seconds in. Submit. Select parameters. So you select solar cooking. You want average installation. These are the figures that I put in. Solar panels, average installation, horizontal surface 0.55. So that's all of those figures there. And then you want your ones for your wind as well. And speed 50 meter average. And there we are, you get your wind energy. Just check those are the ones that I used. 5, 2, 3, 4, yep, those are the ones. So that's how you get that data to put into the thing. Solar energy. So I just put in our coordinates. Here we are 56 degrees. 56 degrees. 19 minutes north, and we are 12 degrees 58 minutes east, plus 1, and then the solar radiation here on average is 1 for January, 1.85 for February, 5.89. Right, so that's the solar information. It's in there. And then the next thing you need to do then is your wind resource, which again you get from the NASA file again. And these are NASA averages over 20 years, I think. So it's December 4.76. Okay, right, our altitude above sea level again off Google Earth is 94 meters. So 94 meters sea level. So that's our wind resource. Right. Now you specify what array you're getting. Now I showed you the picture, that was a 10 kilowatt array up on our roof here, which is 40 panels, so 10, and the cost is in dollars here, so 100,000 kroners is about £9,000, which is about $13,500. So if we put in $15,000 just to be on the safe side. Maintenance of solar panels is actually fairly low. Clean them off now and again, I mean, perhaps get them serviced or something. So I'm just going to put in $100 a year just to have something in there. I don't think you need anything. Now I'm leaving it with no tracking. I am planning on designing a tracking system to actually tilt up and down through the day, tracking the sun and the horizon. It's fairly easy to do, and you can write your own program with an Arduino to control a hydraulic ram or whatever. For now I'm just going to leave that as no tracking. The output current is DC, and then it goes into the inverter, and that comes out as an alternating current. So that's basically what you put in for that. Now your wind turbine, this one's slightly more interesting. What I did, they've stopped making these Southwest Wind Whisper 500s, but it's a 5 kilowatt wind turbine, and I like the energy balls. They're designed in Sweden, they make them in America, distributed. I showed you the picture, about 4,900 units, that's 2,500 watts, so 2 of those would do us. 2 of those cost us €10,000. But I'm just going to put in one of these, and I'm going to put in a capital sum of $15,000. And these do need more maintenance.
but I'm just going to put in 250 because it's not, you know, a lot to get them serviced or whatever. And then that then leaves us with our converter. Now this is the inverter. Now the inverter, the photovoltaics come with an inverter, and wind turbines generally do as well. They're all part of the price. But this is a separate thing. So I'm just going to, I found that if I have a 10 kilowatt inverter, I'm just going to put in a figure for whatever installation or whatever, but just so it's in there, I'm just going to put in 1,000. No maintenance, just so that that's in there, and that's the next thing. Then is we have to say that we're on the grid. So PV because so okay, right, primary load. Okay, now right, so on this add remove, we've got primary load, we've got the photovoltaic, we've got the wind turbine, and we've got our converter or inverter. We're not having a generator and we're not having batteries for reasons I explained earlier. You can always add them later if you want to go fully off grid, or it's going so well and you find you can add some more photovoltaics as they get cheaper. Or, you know, if a wind turbine comes up for $700 on eBay, like the Energy Ball, which did recently, it was in the States, and it would have been worth buying and shipping. Right, anyway, system is connected to the grid, so we're doing that. Okay, right, so now we have our system designed. In the economics, this is an annual real interest rate to work out your return. They have 6% in this. I'm just going to put in 3.5% because it's an opportunity cost of money, and I don't think many people can get a better rate of interest than that on money that they actually have. Project lifetime 25 years, and I'm going to leave it at that. I'm not going to put in the fixed capital or fixed OM costs because that adds them on to the initial capital costs. So I'm not quite sure how that works, but I'm not putting those in. Right, system control. What's this then? Simulation, time step, dispatch strategy, load following cycle charging, separate state charge. I imagine we're load following, but because we're on the grid. Allow system with multiple generators, allow multiple generators to operate simultaneously, allow systems with generator capacity less than peak load. Other settings, allow systems with 2 types of wind turbines, allow excess electricity to serve thermal load, excess thermal load. Well, I mean, that's all, a lot of that's off-grid stuff. So I'm not going to tick any of those additional boxes, we'll just leave the default ones. Emissions, well, we haven't got anything burning energy here. Obviously making this stuff, there's the industrial stuff, but the energy coming off the grid, you can specify green energy, but I mean, if you are into the carbon dioxide and anthropomorphic climate change thing, which personally I'm not, I think it's a good idea to do this stuff just to get off the grid and stick 2 fingers up to the man. But in terms of CO2 and its effect, I mean, my own reading of everything I've read on that sort of leaves me sort of unconvinced or sceptical about CO2, but I'm very convinced about lots of other environmental stuff, so I'm very convinced about doing this stuff, but perhaps for different reasons to you know, other people that are convinced of, you know, those other arguments, which, as I say, I'm not. But be that as it may, I still think this stuff is a good idea. Makes very sound economic sense. So that's what that is. I mean, if you want to do that and sort of pin the badge on you, then, you know, good for you. You can fill in your name, author, that's me, Roger. notes. Sustain. Tool stop. Put what you like in there really. So that's our system, and so now if we press calculate, it's going to work out basically what that system will produce. Oh yeah, photovoltaics will say $15,000. Okay, we've said 15,000 for the rest of the 500 as well. Okay, I'm hoping that we'd get that cheaper than that, but for now that's all well and good. And so now let's have a look at that. It's done the system just with the photovoltaic, it's done just the grid, and it's done the wind turbine. It's done both. Now I'm interested in both, and then you get this table here, and then what this shows you is how much photovoltaic, the net present cost, the wind turbine net present cost, the grid, and the inverter. So those are all costs. So you can see the total cost $31,000 is what we've put down here. This maintenance, replacement costs, blah blah blah. Cash flow does that for you. Right, now this is the electrical PV in yellow, wind in green, and what power is taken off the net. This is the photovoltaic output, and you can see it's kind of a scatter diagram showing periods of the day when it's producing nothing, and then what it produces. Like the red are the high. You'll see at noon. You'd expect that, wouldn't you, to see more energy generating at those times. The wind, then this. Of course, there are less periods of not producing anything with the wind power, which is why it's quite a good idea. And it gives you total production 6,000 kilowatt hours, and PV 13. So we're producing 19,000 kilowatt hours. We're only using 12,000, so that gives us 7,000 surplus, which is pretty cool. There's the inverter output. Remember rectifier, so that's now what have we got here? That's why I didn't do the converter, did I? So let's just close this. Converter to do. On the primary load, it works out an average for weekends, and it's just weekdays. Now that 48.9, we don't actually use that much. We use 35.9, so I'm just going to put 35.9 in there, and then calculate again, and we should see that. Yeah, there we are. That's it. Now you can see annual energy 16,000. We use 12,000, so we've got 4,000 over. Right, so you need to watch that. And so this system, $30,000, which is whatever it is. Just have a look at this again. Right, the wind turbine isn't going to cost that much. The PV. PV is about that, but okay, let me just change this a second. The cost of the 2 energy balls, which gives us our 5 kilowatts, are 10,000 euros. So I'm not sure what the euro to the dollar exchange rate is, to be honest. Put that in at 10,000. Okay. Let's so $27,000. £1.50, isn't it? So it's about 108, maybe £18,000. We don't actually have to buy any electricity ever again here, or not for 25 years anyway, and it gives us a return over and above that cost as well. So costs on PV, wind, PV per cost per kilowatt hour obviously is a lot cheaper. It's 9 cents per kilowatt hour compared to 17. So wind power is almost twice the price, but it still makes sense. Converter. Anyway, you can download and do this all yourself and work out how it works for you. But photovoltaics are economically very, very viable, because also you get rebates on the capital cost. In Sweden here it's about 35%, which obviously reduces the cost even further. In the UK I think it's actually, you get a great deal more in terms of rebates. I think that's because the British government is behind on its Kyoto commitments, and it's a way of catching up. But anyway, that is Homer, and how that works.